So the merge sort breaks, breaks everything down into sub arrays. So remember last night how we had the our bubble sort, and it worked in a section of 2, right? And throughout this section of 2, it split and it switched places and it shifted everything along, right? We have the merge sort here, so we can add our keys. Let's do a whole bunch of keys. So what this is going to do is it's going to take a small section, a slightly larger section, a slightly larger section, and about half, and get all of that in order. And then it's going to go to the second half and do a small section, a slightly larger section, a slightly larger section, and the list goes on. So when we watch this occur, we're switching 2 just like we did, and then we switch 4, just like the bubble sort. Tiny bubble, slightly larger bubble. Slightly larger bubble puts all of those in place. Small bubble, small bubble, small bubble, slightly larger bubble, even larger bubble. Do you guys see how this is happening? Then a larger section of this is in order. So it is taking it out in order to sort the arrays. 1, 2, 3, 4, 5, 6.
So it's just growing by 1?
Our bubble gets slightly larger. So we do a small
5%?
section, a small section, the combination of those 2 sections, or however long it needs to go.
So it's overlapping like this?
It's happening in a structure. So we have the first small bubble, the second small bubble, then those 2 larger bubbles. Then we have another small bubble and another small bubble, those 2 larger bubbles, then those 2 large bubbles. Do you see how that's occurring?
So what's actually happening here is that it breaks down the array into single elements, because a single element is by definition sorted, and then it starts to recursively put them back together until you have they're put back in a sorted fashion until you get back to the full array. So it takes a full array, breaks it in half, how many times it needs to do that to get to a single element, and then it's sorted.
Yep.
And then it puts them back together.
Over and over and over again.
Yeah, over and over and over, recursively.
So it's taking half and then it's checking that half and then it's taking the other half and checking that half.
No, it doesn't check anything when it's breaking it apart. It just breaks it apart. So if you have, so the first step in merge sort is you've got this big array, and then it's cut in half, and you have 2 arrays. And each one of those are cut in half, all the way to get to the point. The goal here is to get down to a single element array, right? So you'll end up with a bunch of these. Now you've got to put them back together, and this is where the checking starts. So it'll compare this one to this one, and whichever is larger, it'll put it in the first position. Then it'll check this one with this one, and so on. And then when you get to these larger arrays, where you have, like, let's say you have 2 elements, then it's going to check this one with this one, this one with this one, this one with this one, and this one with this one, and put them back into order, and keep going until you get back to your original array.
Okay.
Oh,
I think I get it.
That was really excellent explanation, Doc. Thank you.
You're welcome.
You need to put your mic back down. I can hear you.
I hope where I can.
I said, thank you, Doc.
You're welcome.
I do remember that Doc and Harry played a big part in me understanding this last time, so I'm not so. Thank you for being here.
You're very welcome. But you'll see, when you start to break down the code, you'll see exactly what I just drew out. This was like just the shortcut version.
All right. So who's going to be my victim and share their screen then? Hi, Henry. Do you have the file ready to share? All right. You looked really guilty. I couldn't help but pick on you there. So we are in sorting. Very good. Oh, look at that. We already kind of got a little bit started there. So first we have our elements are the length of array A plus the length of array B.
Whose screen is this? Whose screen is this?
This is Henry's.
Oh, can you zoom in at all, please? Maybe.
I really like your theme, Henry.
Thank you. Is this good enough, or should I zoom in more?
That is really great for me. Is that good for everybody else?
Yeah, I mean, as big as you can make it is fine. That won't.
I'm good. I can see it.
Thank you.
All right, I can see it without my glasses, so I'm good to go. So our first to do, this is just going to be a merge. We have a merge, and then a merge sort, and then we'll skip over these stretch problems because I don't have the answer key, and it's probably going to take us a while. And then we're going to go over searching. So first thing, we have two arrays of different lengths that need to be merged together. So what do we have at line 3?
We're adding the length of both A and B together into elements.
Right, so we will have the length. So our elements is the length. What is this merged array equal?
It's merging both of the arrays times to this empty list starting at 0.
Is that is that an empty list?
No.
That is a 0. And what are we doing with that 0?
We're just filling an array with all zeros again.
Yeah, very good. Tita, what was that called?
Oh, filling an array with all zeros.
It was our buckets. We were talking about buckets last night.
That's like, yeah. Is that technically initializing or instantiating a bucket or like?
Yes, we have initialized our bucket.
Because that's like we're allocating memory that way, right? By
Yes.
defining. Okay, that's
Awesome.
apparently that thing is conceptually.
All right. So the next thing I need is an index A and an index B.
Oh, we forgot the IZ, but it's okay in line form. But just saying in the comment. No worries.
Initial.
After the L should be IZ, but I don't mean to be nitpicky, just in case you wanted to know.
Right here, IZE, initialized.
After the L.
Initial.
I.
I'm having a brain fart. I'm sorry.
Initial IZED. All right.
Initialized. Okay.
Need an index A. And an index B. And then we need to initialize our index A and our index B. Where do our indexes usually start?
At 0.
Right. Excellent. Index A, index B, we don't know where they are. They're starting at 0.
I have a feeling Doc's gonna start pulling her hair out soon.
Can we please make this Pythonic. So remember, in Python, we use underscores. We don't use camel case. Give me a snake. Index underscore underscore. Very good.
No caps. Caps are constants in Python. By convention.
All right. So now I have some nice Pythonic index A's and B's. Now we have a merged array and our two starting indexes. So now we're going to initialize a for loop. For I in range, length. What are we going to use the length of? Anyone take a good guess?
Elements.
What's the other thing we have? Merged array. Good. If it was in elements, it would be in range. Well, we were talking about this earlier. So you could actually do something in range and then just put a number in there. That's totally something that you could do. But in this case, in range length of the merged array. If the index A is greater than the length of array A minus, and I'm putting done. Oh gosh, we're running out of time. Minus 1. Then, so we're going to check if we're at the end of the first array. If there are no more elements at the end of the array, the first array, we're going to add the rest of the B array elements. Merged array at I equals array B index. B index. Array B, B index. Very good. Index B. Index B plus equals 1. Next line. Next line. There you go. So when you're giving Python instructions, do you remember to put them in a nice happy order? Python likes lines. JavaScript lets you do what you want, as long as you're inside the curly bracers. Okay. So we're checking if we're at the end of the array. And if there are no more elements in the array of A, add the rest of the B array elements. Now we're going to check if we're at the end of the B array. So elif we're checking our B array. If there are no more elements in our B array, we're going to add the rest of our A array elements. So now we're going to add our A array elements. Look at line 11. Very good. And then awesome. Now, if we're not at the end of either array, else, if array A at which index goes with array A, guys?
Index A.
Excellent. What do you think, Henry? Let's look at that pattern. If index A is greater than length, blah, blah, blah. If array at index A, to get rid of that if, it doesn't like it. Else colon, else colon, new line, if, beginning of line 17, if, there you go, is greater than what?
Be the same thing with array B. Oh, sorry.
Yes, very good, Tita. Array B at index B.
Right.
Now we are merging two sorted arrays. So we are already assuming that this is 1, 3, 7, 12. And the other array is also sorted with 2, 5, 16, 20, right? So we have two arrays that are already sorted. So this is why we can compare index A to index B like this. Because we already know that they're going to be in order. So how do we switch two things?
You could just reverse them. I don't know.
We need to add this to our new merged array, right? So first we have this big bucket, and we're at index I, and our array index A is greater than our array index B. So what goes here?
The array index B.
Right,
Like,
how do I assign it? Tita, tell me, how do I assign it?
let's see. Can you say? You mean, oh, wait. What's the name of the bucket array? Elements.
Merged array.
Oh, yeah, that's what I was gonna say. Oh, merged array. At index 0, I guess.
Index I.
Oh, okay.
We're in a for loop. Index I
equals.
That's a comparator.
Dot append.
Equals.
Oh, just equals.
A single equals. This is an assignment. Double equals is a comparison.
Oh, thank you. Okay. And then I guess we do array B at the index of. Are we at 0 right now?
B. We're at index B.
Oh, okay. So B.
So remember, we're using
index B. Sorry.
These are our little variables like X and Y. So we want this, our index of I, which is here, or it could be anywhere else, to be equal to wherever we are in array B.
Man,
Okay?
I wish I'd been joining you guys like since you started this. Wasn't it like a good month or so before you started this?
We are starting the 3rd week.
Oh, so I just missed like the first one?
You missed 2 weeks.
Well, I was with the last one. Oh, 2. Okay, never mind. Sorry.
Yeah. And then what do we do with our B index?
Are you just going to compare it to the A index?
Oh, now we have to increase our B index by
Plus equals 1.
Yes. B index plus equal new line. Our B index, not our array B, our B index, our index of B, has to increase, right? Right. So this is increasing here. We're not removing anything from our index, from our length of the array A or our length of the array B. They're staying at the same spot. So we have index A, we have index B, and we have two separate pointers that start off here. And then we have a merged list, and our merge is going with our is our index, is our I, okay? So if we use index B, cool, we're just going to pretend that's not there, and all we've done is, in all actuality, is just moved our pointer down, and then we've added this to this array. This is no longer a placeholder 0, it's whatever was at our index B. Does that make sense?
So we have list in a minute. Yes.
Cool. So, Henry, can you write our else?
For the other one.
Yep. So, if this, else, nope, this needs to go in by 1 tab, please. There you go. Else. We don't need an if because we're just going to assume that if it's not greater than, it's less than. So our merged array at I is going to equal what?
It's going to equal the array A at the index of A.
And then what do we do?
And then we're going to move it +1.
We're going to move our pointer +1. And what do we return at the end of all things? Oh, actually, it's already returned for us. So ignore that. It's already being returned. All right, so we have got 1 merge done. All right, so that was our merge. Does everyone understand how that worked? Thumbs up, Henry. You just looked at your hand. This is not
No,
a
it's
gesture.
because there was a mosquito. Sorry.
Yes. No.
I just want to talk it through, if that's fine.
Yes, by all means.
So we're taking both of the length of the array A and array B and naming it as elements, and we're initializing our bucket by multiplying the elements to an index of zeros, which is
no, we're multiplying the elements by a list of 0.
by a list of 0.
So Python can do a cool thing that JavaScript does not do. You can print things multiple times. You can multiply individual characters. So what this says, if length of A is 7 and length of B is 8, our elements is 15. So we said, I want you to put this 0 15 times into a list.
Okay.
So we have an array that has a length of 15 now.
Right. Okay. And we're setting our pointers to 0, naming it A and B, and we're going to do a for loop within the range of the merged array or our bucket. And we're doing an if statement. If the index of A is greater than the length of array A, we're going to subtract. We're going to do -1 because we don't want it to go all the way to the end, right?
With the length of the array -1. So index of A is currently at 0. The length of the array -1, because our length of array is going to be 15, length of array -1 would be 14 because it starts at 0. So if it's greater than this -1, right? So if 0 is greater than -1, that's the only time this would ever stop, is if we got down to an empty array. Got it?
Mm-hmm.
What line is that? The 10 that you're talking about?
Yep. So this is the only time that would kick in. So if the index A, so for example, so basically if we get to the end, so index A goes to the end of our array. So if we, because we're increasing it down here, right? Okay, so here we have our array A. We have our pointer that we initialized, right? And we count, we get to the end of the list. Our index A increases by 1. Oh, this is terrible. What happens? We can't compare it to anything, right? So then this kicks in and we add the rest of the sorted array of array B to the end of our merged array.
So basically that's line 10 is so we don't get an out of bounds error.
No, it is so you don't get an out of bounds error, but it's actually so that it will continue, because we could have it set up to stop it.
Oh, okay.
But instead we're adding the rest of the B array into the array at I.
Okay.
So we're looking to see if we've added all of the elements of the first array.
Line 10, that's what that is.
Mhm.
Okay.
And then line 11 goes, okay, great. We've finished our first array all the way to the end. Great. Well, array B has already been sorted. So we already know those go from least to greatest. Just add the rest onto there. Boop, 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 boop. Done. Okay?
Mm-hmm.
Awesome.
Then we do an else if else, which is basically doing the same thing as this, but for index B. Else if index B is greater than the length of the array, is gonna boop, 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 do all of that noises that Ava did, and put the array of A at the end as well.
So we're going to add everything to the merged array in order. All right. So this is our I'm going with the wrong word. Oh no, wrong word. Someone help me. We're making sure that this doesn't go through. It's I'm going with use case, and use case is the wrong thing. Edge case. These are our edge cases that we're checking for. Okay, so these are our edge cases. So remember, like with our, when we were doing our nodes, we were making sure that our node was even there to begin with. So that's our edge cases. All right, so now our really simple part of the merge.
Else if the array of A at the index of A is greater than the array of B at index of B, we're going to merge the merge array with the
So what are we not merging? We are
adding,
replacing.
replacing.
Because what's currently at merged index I? The number 0. And our merged array is a bucket full of zeros. So we're making that 0. It's no longer the 0. It's whatever number currently exists at the array B, index of B. Okay?
Okay.
Else?
Else replace the merge array with the array A.
Not the merged array. We're replacing.
Or replacing the merged array at the index of I, which is all just zeros, and replacing it with whatever the array A has
At
the index of A.
Very good. And then what are we doing?
Adding it plus 1.
What does that do?
Move the pointer to the right.
Yes, it moves our pointer to the right. Very good. Is that more clear for you, Henry?
Yeah.
Awesome. All right, so now we have already watched the merge sort. So now we're going to go through the merged sort. So first thing we have to find. So as Doc said, where she explained it very well for us, first we have to take this massive array and we cut it in half. And then we take a left and a right, so we have 2 arrays. And then what do we do?
You keep doing the same for each of those arrays until you get single individual elements in
Yes.
their own. Are they actually considered lists though?
Yes, they're going to be lists with an index of A, at an index. However, we do in fact go all the way down. So what's the first thing we have to find? If
Where
we're
the
going to cut
halfway
something.
point is.
Yes, Carmen. All right, we got to find the middle. How do we find the middle?
I'll be the sound effects department.
How do we find the middle?
Oh, didn't we do like? Do we do like last time where we floor it by 2? Wait, maybe not.
Yes, exactly.
This okay.
So
I knew that.
middle equals middle,
Oh, floor divide. That's what I meant. Sorry.
the length of array, and floor divide. Do you remember how to floor divide it? This is Python.
It's the double slashes,
Very good.
which is like the comment in. Is that Java? C++, right? I forget which is the one.
It's
Or maybe
the comment in JavaScript.
oh JavaScript. Okay.
All right, so the middle is the length of the array with a floor division of 2. Awesome. So the left, now we're going to have to do a nice little division. Carmen, we were talking about this earlier. What is the left?
What do you mean? Like how we said we were going to keep going one way until
way earlier. You and me having a conversation about lists and stuff. We were talking about
slicing and splicing and all of that, right?
Yeah. So how do we get the left slice?
You could just slice it down the middle.
So
it was like left side dot splice. And is there a way that you could do like the colons with this one?
So it's going to be, oh, Henry. Python, left side equals array, brackets, colon. What do you think, guys? What should go there?
I can't remember if it's a colon or if it's like an
We went through all the trouble of finding it.
Yeah, we're defining range.
Array?
Is that different? I mean, it's similar to text.
We're not defining a range. We are going with the array to the middle, so we're cutting it. So the left side is the array, colon, middle.
Is it really? Oh, that's interesting.
So it's just like in JavaScript where we have like 1,3 or whatever. So this is inclusive of the first, so we don't even have to put that there. It's starting at 0. Exclusive of the second, which would be, in this case, we already found that number, the middle.
The middle.
So, Henry, what do you think? How do we get the right side?
Basically the same thing, right?
The same thing except slightly different. How are we going to do it?
Oh, you move middle. Oh, sorry.
No, speak up. Go ahead. You got the answer. Go ahead. And tell
Henry, do you know or you don't? I don't want to rob you of it.
I think I know.
So we want to include the middle this time. We're going to use the word middle again. Where does it go? Left or right?
Left.
Yep. So you see how beautiful this is? So now we have these 2 wonderful splits. How lovely is it? Is everybody happy with this? Does it make everyone pleased?
Yeah, it makes sense.
Yeah.
All right.
Cool. So because in general, when you have a list with the colons, isn't it generally in Python like begin, middle, begin and increment, like, or it doesn't apply in this case?
Doesn't really apply in this case. We're just looking for the middle.
Okay. Yeah, that's confusing to me.
We have the left and the right. The middle is the number of the index of the center of the list, right?
Okay.
That's all we have determined thus far. And then on the left side, we have cut the list in half. I'm going, cool, I want the left half and the right half. Now we have, so what we have been given is an unsorted array. And we're going to sort using the merge sort. And unfortunately, I don't have the merge sort in place or the merge in place. I need to do those stretch goals myself.
But
So we've cut this in half. That's where we're at.
But can I ask a quick question? Yeah, like what I was just asking, are you sure it's totally different? Because doesn't Python see splicing as still like, you know,
This
you start
slicing.
Oh, sorry, slicing. It dices, it splices, it slices. Okay, anyway, doesn't it, you know, anytime it sees a colon or two colons, doesn't it always kind of, or I don't know, does it read it as like begin here, you know, and
yes, on the first half of this colon is a 0.
Okay.
If it's a 0 or the end of the list, you don't have to put the 0 there.
Okay, but the same syntax applies is what I'm asking.
Yes, the same syntax applies.
Oh, I thought you had said no earlier. Thanks.
No, you said head and end.
Oh, I thought it said, yeah, begin and increment. So it's, or start, stop, increment is generally how the, you know, if you have colons inside square brackets.
Yeah, we don't have to put start or stop.
Okay, no, for sure. That tricks me, confused me. Anyway, thanks.
Okay. JavaScript is not as kind. Python is better. All right, so we have the middle and we have sliced it. All right, so now if there's more than one number in the left array, well, then we have to slice it again. So how do we check? If there's more than one number. So if
If left side is greater than or equal to 2, which would be more than 1, then you could just.
Well, the left side is an array.
You need a length of, right? Or
yes. If the length of the left side
I'm on fire.
Okay.
is greater than 1. Always go for the simplest part in the center that you can.
Mm-hmm.
Is greater than 1, then what do? It's our friend recursion.
So what are you
We're gonna recurse. How are we gonna recurse? What's the name?
First, we need a base case.
merge sort?
Merge sort. Good. And what do we put in there? And yes, we do need a base case. So our new left is going to be. So base case left side equals merge sort. Ava, you should go to sleep more frequently.
Merge sort. It sounds like a Monty Python thing.
It does. And what goes inside? If we're gonna invoke it, what goes in there? We gotta pass something in.
The array.
Which array?
Mm.
We've got 2. Which one? The left or the right?
The left.
Very good, Carmen. Awesome. Now, let's do another if.
You don't need. Oh, okay. Nothing. It's on the same level.
If the length of the right side is greater than 1. Awesome. Now, this is not recursion, but it's going to use our helper function. What it would do? Our array equals. What's the name of our helper function? We just wrote it in our last class 5 minutes ago.
Was it the merge sort?
Merge array?
Yes, the merge. Yes, it was just called merge. It helpfully highlights for you in orange. What do we pass it? And we pass in 2 things.
The left side and the right side?
Both arrays.
Yes, the left side and the right side. Excellent. So, who wants to talk through this? We're done. This is all it is. Isn't it beautiful?
Yeah, it looks pretty cool.
I like, especially with the colors.
All right, so who wants to explain this?
I mean,
All right, Tita, you've been talking
Okay.
a lot, so you get to explain it.
oh, okay. I was gonna try. All right, let's see. Because I learned that in math, like when you don't know, you should just put yourself on the spot. I mean, when you're not sure. Anyway, it might not die. All right. Anyway, here we go. Merge sort. Okay, so first we found the middle element by
The
doing a
middle index.
okay. We found the middle index of the middle element by doing floor divide on the length of the array. Then we so now does that mean now we have two subarrays basically?
Not yet. Now, all
yet?
that we have right now is we have the number 8.
Oh, okay.
Line 31, we have a number,
Okay,
an index value.
an index value. Okay, so then we're initializing an array that will contain the elements from the beginning of the array until that middle index 8, or well, whatever the theoretical one is. And then the right will define a right side one for the other half that goes from that index, the middle, to the end of the array. Correct?
Absolutely.
All right. Now 34, like then the first if statement expression. Anyway, if the length of the left side is greater than 1, meaning we were checking to see if for some reason there were 2 elements in that index. Is that correct?
So if there's more than 1, so if we get all the way down, our merge sort, all we want is 1, right? We want to go all the way down.
Well,
until we
I'm
only
not
have.
sure what you mean down. I'm not visualizing
So
down. It's not like
we
a tree.
start with a massive array, and then we cut it in half, and we go all the way down.
Oh, because we keep
cutting it in half
Oh,
and
okay,
cutting it
okay.
in half using recursion, cutting it in half and in half and in half and in half until we only have one number.
Okay, I get it now. Thank you. That's clear. Okay, so sure. So line 34, like Ava said, we're checking to see if we've basically come down all the way to each element of the array being in a list. So if it is greater than 1, then we're going to continue to recursively merge sort it.
So we're going to keep cutting it down until we only have one thing.
Okay, cool. Same thing with the right side, and then we return. Well, we're defining the new array as both of those. Oh, we're passing both of those arrays.
So we get down to 1.
Oh, okay. Well, I'm seeing this comma, but we're basically merging those two, and then we're calling it an array, just ARR, in line 39.
Yes, so we're going to have this left and right. So first we're combining these 2, right? And then we're going to combine 4. And then we're going to combine 8. And it's going to go all the way up. It's a little confusing to visualize, but that's what happens.
Well, that's cool.
That's why we stared at that visualizer at the beginning of class. So does the merge sort make sense, our very recursive friend?
Did you used to teach before Lambda School, Ava?
Yes, I've taught English as a second language and music and a couple of different instruments.
Oh, okay, no wonder. Yeah, you're great, thanks.
So, everything good? Awesome. So, that's all we got. So I want you on line 49 and 53 to write pass. And that's just going to keep that angry line from yelling at you. These are stretch goals. I did not do them, so I don't have the answer key, and I'm tired. So let's move on to searching.
Yay.
Okay, so we have implement a recursive binary search. So we have our array, which is going to be the array that we're given. Let's imagine it's 50,000 million things long. We have the target number, the target that we're looking for, the thing that we know. And then we know the start and the end. So with that in mind, first thing we're going to do, our base case is that the target is not in the array. So our first edge case. So if start is greater than end, because with a binary, we're trying to get to the middle, right? So if we finally get to the point where our start is 8 and our end is 7, we've gone through the whole thing. Okay? Imagining our start is 0 and our end is 10. If we get to the point where our start is larger than our end, we're done. Okay? So if start is greater than end, we're going to return -1. Not return -1. Return -1. There you go. -1.
How would the start ever be bigger than the end though? I've just not remember the mechanism, I guess, of the binary searches.
You'll
Just
see.
put it in half and half, right?
You'll see.
Oh, okay, cool.
You'll see in the rest of the code.
There's nobody behind the curtain.
All right, so that's our first case. Else. So how do we get our midpoint, guys?
Our favorite friend, floor divide.
There's actually an even there. And how do we get our floor in this case? We got something really cool that we get to do.
What is that? That thing with the percent sign. Do we do that?
No, the cool way we have
Aw.
start plus end floor divide too.
Or that.
Yeah. Use what you're given.
Wait, what was I thinking with the what's that called again when you divide when you use it?
Modulus. You're thinking about a modulus. That is used to return if you're dividing something and you want the remainder.
I know, but did we use that yesterday?
No, we did not. We do not need a modulus, Henry.
Sorry.
So first at line 8, that's going to be the midpoint or the middle, right?
The middle number.
So if array, it's going to be inside this else statement, Henry. There you go. So if the array at the midpoint equals the target, a comparator in Python is how many equals?
2.
Okay. Good. Thank you, Tita. I like having someone who actually chimes in. Chime in more, guys.
I'll have to get my bell. So, do we need the index there? Array at middle?
Yes.
But we don't.
If the array at the middle, yes.
But we didn't. We have to define middle.
That should have been at 8.
Yeah, middle equals.
So A should have been our midpoint. Henry wrote it in the comment and then he forgot to assign it.
Cool.
So if the array at the middle is the target, then what do?
Splitting it.
So no, we found it.
Oh.
So we're going to return the index of our target. So return what's the index? No, the index.
Middle.
Index. Yes, return the middle. Very good. All right. Else if, elif. It's got to be inside that if statement. Thank you. Else if, what is something else? So else if means we're going to add a condition.
He does have to indent 4 more, right?
Nope. He's exactly where he needs to be.
My bad.
I need a condition. Inside of that. Yep. So when you have an else, you don't need anything to be a condition. If you have an else if, we have to have an if statement there. So else if, so let's check. If the array at our midpoint is less than the target, What are we going to do? Return.
Return the
It's everybody's favorite friend.
Doing recursion again.
Yeah. So we're going to return the binary search of the array target start, and what's our new end? Sorry, I did it backwards. Array target. What's our new starting point? I did it backwards.
Is it middle?
It is the middle
Index?
middle plus 1. Midpoint plus 1.
Oh, because we want to move one over?
Yep.
Okay.
Because it's inclusive. Put that in a set of parentheses. That way it knows. There you go. And then our end. So we've shifted. All right. And else. Up. There you go. So else, what are we going to return?
the
Everybody's favorite friend. I want you guys to think of me doing a little dance every time you
The
do
binary
recursion.
search.
Yes. Yes, Carmen. So return the binary search. What do we put in there?
the array target, and it would be the start and then middle minus 1.
Very good, Henry. Excellent.
Wait, could we see a visual on that? I don't know.
Yeah, let me draw a little picture, and then after this timer goes down, I'm gonna go to the bathroom, and then we're gonna do the agnostic binary. All right, so here is our start, right? So our start is at index 0, and our end is at index 10. So we go through. Middle is equal to our start plus our end divided by 2. 0 plus 10 is 10 divided by 2 is 5. Yay, I can do much math. All right. Array. We were looking for a 3. The array is not 5. Oh no. Okay. Is it less than, is our array at the middle greater than the target? No, it's not. All right. Is array at the middle less than the target? Yes, it is. Binary search. Array. Target. Start. Our start is our start at 0. Middle. It's not 5. We already know that the middle is not there. Minus 1, 4. Okay. 0 to 4. You got that?
I think so, yeah. So it's actually not comparing indices, it's comparing elements.
It is this is an in this particular instance, we are in fact looking just for the number.
Okay.
So it is the array. If we were looking for the we're looking for the index. All right. So that was it. You may in your code signal, you may actually see this as a thing that they want you to do in this exact way. So you've got it all written. It'll be saved in your little GitHub accounts. This is how it works. Tita, do you understand what moving the middle by 1 is doing?
Let's see. Isn't that helping us break down into smaller, like, to keep doing the splits in half?
Well, the reason that we're moving it is we've already excluded the middle because we already know that it doesn't equal the target, right?
All right.
So we're
then
just,
it's the one before it.
that's the one before it or after it. So we already know.
Yep.
So we
Oh,
can just kind of like, this is this optimization, right?
Okay.
So this, we could just do we could just do middle end, but this plus and minus one just makes it like that much faster, which matters when you're doing stuff that has like millions and millions of things. Doesn't really matter if the list is only 10, but if the list was like 3 million, being able to exclude one at a time would actually make a bit of a difference. So we're going to go through the agnostic binary search and then we'll be all done. Okay, so the agnostic binary search will find the target regardless of whether the input array is sorted in ascending or descending order. Okay, so it's going to work if it's either greatest to largest. Wow, if it's either smallest to greatest or greatest to smallest. Greatest to largest. It's going to be a short list. Okay. So first, if array at 0 is less than array at length of array minus 1. Awesome. So what this is checking, right, is that this particular part right here is we're going to check if we're sorted from biggest to smallest or smallest to biggest, right? So that's what this checks for. Hun, can you give the cat the kidney food? He's being a pest. Yes, I know. Yeah, I know, buddy. He's going to give you food. You're being a butt. Okay. If array, so we're going to check that it's either smallest to greatest or greatest to smallest. So if it is sorted in ascending order, return. So we've already checked that. Delete the if. So what are we going to return? What would already do this for us?
We're going to return
Something even smarter. Super smart.
Recursion.
No recursion. Recursion's our friend. Recursion's not super smart. What's super smart?
I don't remember.
It's a helper function. So we're going to go back and we're just going to, it's already sorted from smallest to largest. So just return the binary search. Not the agnostic. Go up. What's that other one called? It's just called the binary search. Okay, and now what do we need? I need a start, a target. So I need my array, my target, my array, passing in the array, my target. What's the beginning? Where does it start, Henry?
at the array at index 0.
We're just going to return the index number, which is
0.
And
And
what is the end?
uh,
How do we find the end index? Length.
length of the array minus 1.
Yep. And then what do we do to make sure that it knows that we don't want it to do so many crazy things? We got to wrap it in a
Parentheses.
Very good. Cool. So that's the first half. There's a really cheap way to do this. Can anyone think of the cheapest way to do this?
The cheapest way I can think of is just to return true if it's true and false if it's false.
The cheapest way to do an agnostic binary search is to array.reverse and pass it into the binary search.
Wait, what?
Okay, so the agnostic search goes from is going to work whether or not is the least to the greatest, right?
Mm-hmm.
The binary search only works if it's from the least to the greatest. You're given an array, you don't know whether or not, no, not agnostic. Not agnostic. That work, and get rid of that part. First we have to invert the array, and then we return it that way. That is so cheap and dirty, and I'm not going to let you do that, but that is an option. You could do that. I would probably do that.
Wow.
Is
That
it
is
is it 1 or is it
negative
minus?
1.
I don't. Okay.
It's actually a method is array.reverse.
Mm-hmm.
Huh.
So it's array.reverse. Invoke. Invoked. Yeah, then delete the rest of that. Okay. But that's cheap. We don't want to do that, right? We've got more integrity than that. Right, guys?
No, we don't.
Yes, we do. So, else left equals 0.
Wait.
Right.
well,
So this is our left index.
Okay.
And now I need our right index. Our furthest right point is what?
Or
Length. There. Yes. Yes, exactly that. So, now we're going to do this non-recursively. So we need to do this with an iteration. How do we do this with in a kind of linear way? What kind of a loop do we use that is like recursion but isn't recursion?
A while loop.
Good job, Carmen. So, while left is less than or equal to
the target.
right. Colon. All right. While left is less than equal to right. What do we have to define next? What do I need?
The base case.
The middle. So what's the middle?
It's equal to the array wait.
Left plus Carmen, help me out.
I don't want to. I feel like I've already done this one.
You have millions of
Basically,
times.
you're just gonna keep searching right until there's nothing left.
No,
So it's
we do left plus right. How do we find the middle? Left plus right. Yes.
Oh, you were doing that. Okay. No,
Yes, we're
I
finding the
wouldn't have
middle.
gotten that.
Left plus right divided by 2. And then so the first thing we check now that we have the midpoint is if
the left is
the target is equal to what?
equal
Double
to,
equals is a comparator.
if the target is equal to the array
at
the index of middle.
yes, the array at the middle index. Congratulations, we win. So what do? We return our index, which is the middle. Our index is the middle. Our index is the middle. Okay, so the middle is the index. The array at the middle is a different thing. So we're returning the middle. This is the index. All right, so now this is a binary search, so we have to check left or right. Else if, elif, the array at the middle is less than the target, right equals, how are we going to reset this?
We're going to,
So the right is the,
uh,
we're cutting it in half. So the right is now been moved from the end to the,
middle.
yes, the array middle. Rather the, actually, my bad, the middle minus, not the array at middle, the middle minus, perfect. All right, else. So we reassign the right, so now we've got to reassign the
left.
no, we don't need that. Because else
All right, because it's,
assumes,
okay.
yep. Perfect. And now if it's not there at all, return, oh, all the way on the outside. That's our, this is our, not that far on the outside. There you go. Return -1. Okay. Do we understand this?
So at line 30, we're
checking if our input array, we're going to check if the input array is in the normal sorted array order. Because if it's already sorted from smallest to greatest, in this case 16, then we don't need to write anything else. We've already written a binary function, go up. And then it's going to run this lovely recursive binary search.
okay.
Otherwise, continue on. And we're going to give the left and the right these numbers, which is we're going to give this this index, and the right is going to be this index.
Okay.
So as long as the left is less than or equal to the right, though this loop is going to run the entire time, okay? If the target is the middle, now this is our exit strategy, right? Always have an exit strategy, like a bad date, always have an exit strategy. We're going to return our index. Our index is the middle, right? So congratulations, we found the thing we were looking for. If we didn't find the thing we were looking for, and the array at middle is less than the target, now remember, the right is less than the target, because this is 0, and this is 10 million, also written here as 16. because this is a reverse order. So if the middle is less than the target, the right is the middle index minus 1. Okay? So we're just moving it. Otherwise, the left is going to be the middle minus 1. So we're cutting it in half. Everything clear? Does that make sense? Does
Yeah.
anything not make sense? Cool. That is the agnostic binary search. Finished just before 10 p.m. and everybody has to go to class.
And so the definition of agnostic binary search is basically deciding whether or not it is from largest to smallest or smallest to biggest.
Yes, agnostic
Okay.
means it doesn't matter. It'll work either way.
Okay. All right, cool.
Everyone clear on that?
Yes, Ava, thank you so much.
Anytime. Tomorrow we're going to be going over the algorithms and how to write a first pass solution and how to write a first pass solution. So Carmen, you and I were talking earlier about rule number 1. What's rule number 1?
Just make it work first.
Exactly. Our first pass solution is make it work. So that's what we're going to be doing tomorrow. We're going to just be guessing and doing our best to come up with some solutions.
Okay.
And they're not going to be pretty. They're not going to be fast. They're going to be gross. It's going to be so much fun.
Okay.
So you mean Ava's not going to have an answer?
Ava's totally
key,
going to have
right?
an answer key, but I'm just going to smile and laugh at everyone.